Today we're going to be starting lesson 7.3 on polynomial and rational inequalities. At this point, we're all pretty familiar with interval notation. Soft brackets like these would indicate a less than or equal to situation. Hard brackets like these would show that we are including. So if you have the or equal to sign underneath here, the U just means a union of two separate solutions. On a number line while we're graphing, if we're using soft brackets, you'll use parentheses on the number line. If it's a hard bracket, you'll place the hard bracket, and then of course going left or right. So we're just going to start by solving some simple inequalities here, and then putting them on a number line. So I'm looking to solve this first one here. I'm going to distribute. And then we're going to set everything up to solve. X is on one side, numbers on the other. So we'll have 2x here is going to be less than negative 10. Dividing by 2, we get x is less than negative 5. In interval notation, we're going from negative infinity to negative 5 with a soft bracket because we are not including negative 5. For the number line, you just need to put the key components on there. We don't need to put spaces on everything. Since it's a soft bracket, we use a parenthesis, and we shade towards negative infinity. Number 2 is what we know as a composite function. You can either separate them out or solve them together. Just remember, whatever you do to the middle, you have to do the same thing to both the left and the right. So here, I'm looking to isolate the x. I'm going to subtract 4. But again, we're going to subtract 4 from every place in there. So we're going to get minus 6 is less than negative 2x, which is less than or equal to 2. To get x by itself, we're going to divide everything through by negative 2. And when you divide by a negative, you need to remember to flip your inequality. So over here, we get 3 now is greater than x, which is greater than or equal to negative 1. In interval notation, we have a hard bracket due to the or equal to part here on the left. Going to 3, interval notation, we're always in the way of the number line. So negative 1 obviously be on the left, 3 on the right. Again, we only need the key components on our graph, showing a hard bracket, a parenthesis, and all the solutions are included in between. For number 3, we're going to distribute. Gathering up x's on one side and numbers on the other side. So we've got x is greater than or equal to 3. Greater than would be heading towards positive infinity. We do have a hard bracket on the 3 because, again, of this or equal to. Only main components on the number line, and now we're heading towards positive infinity. All right, so let's look at some others. Let's look at some other polynomials here. Okay, when solving these guys here, again, we're just going to solve the equation, just being mindful that we do have an inequality. The first thing I see here is that we can factor out an x. They each share at least one x. And then x squared minus 4 is a difference of two perfect squares, so that is still factorable. And you just want to get what x equals at first. So here, x is equal to 0, x is equal to negative 2, x is equal to 2. In the order of the number line here, we're looking where things are greater than 0. So we're not going to have anything below that. So our answer here is going to be negative 2 to 0. And then from to infinity. And you're probably asking, how do you know that at this point? So what you want to do is once you get your answers here, so we have negative 2, we have 0, and we have positive 2. And what you'd want to do is just test each of the intervals. So for example, if I put negative 3 back into our original equation, we get a negative value. If I put -1 into our original equation, we get a positive value. If I put 1 in, we'll get a negative, and if we get like a number like 3, anything in that interval would be positive. I'm looking for where these values are greater than 0, and that's where these intervals are coming from. So it's coming from -2 to 0, and then 2 to infinity. You can put the union sign inside of there if you'd like. Number line wise, we'd have -2 to 0, and then 2. These guys would both have a hard bracket on there. This guy would also have a hard bracket, and then heading towards positive infinity. All right, so for number 5, let's get everything over to one side of the equation first. This is factorable. You are looking for two numbers that multiply to be 12, that would add to be 7. So it's going to be 4 and 3. Since this sign's a plus, they're both going to be positive. I find x is equal to -4, x is equal to -3, and again, we're just going to use those values to figure out where things are going to be. Now, in this case, less than 0, so we're looking for numbers to be below 0. And we're going to test those intervals. So if I put -5 back into this original equation here, I get a positive value. If I put -3.5, you just need to pick some value in between -4 and -3, we get a negative value. And if I picked a number like 0, we get a positive value. And again, we're looking for this guy to be less than 0. So the interval where that is happening is between -4 and 3. And we're going to have soft brackets on there because this equation, this inequality here, does not have the or equal to. On our number line, we would look like -4, -3, and both would have soft parentheses, and it's every value in between. Let's take a look at number 6. Let's first distribute. And also bringing that 5x over to the other side. And then let's arrange these in a way that a normal quadratic would look. And this guy factors into 3x plus 2x minus 3. So here we get x is equal to -2/3. Here x is equal to positive 3/2. Then we need to run our test. So -2/3 would be on the left. Positive 3/2 would be on the right. If I pick a number less than -2/3, let's say like -2, and I plug that into my original equation, we get a plus value. If I pick 0, that's an easy one to pick in between here, we get negative. Anything above 3/2, so for example 2, you would get a positive value. We are again looking for these guys to be greater than 0, according to our inequality here. So it's going to be greater in this interval where we see the pluses. So we're going to be going from -infinity to -2/3 with the soft bracket because we don't see the or equal to. And then we're going to pick up again at 3/2, heading towards positive infinity, number line wise. We'll have the soft brackets on each and then heading towards the infinities. Okay, so let's turn our papers over. And let's talk about rational inequalities. We're going to make sure we only have one fraction on the left, so we need to combine those. We're going to find critical numbers. I need to know where the rational equation does not exist, so it's going to take our focus to the denominator, and then where it's also going to equal 0. All right, so let's look at problem number 6. So I'm looking at this problem here. If I look at the denominator, I could factor out a 2. And I know that x cannot be -4. That is going to drive that denominator to 0, and we just can't have that. To solve where a rational equation will equal 0, you just look to the numerator. If I were to solve that piece there's nothing to factor or combine. I know x needs to equal 1. So I want to know where this is going to be less than 0. Again, we're going to run our test. So our critical values here are -4, where it equals 0, and then 1, I know it cannot be. So you might want to put not equal to just to remind yourself there. Plugging in critical values, if I were to put -5 in here, I'd get a positive value. If I put 0 in, I get a negative. And if, let's say, I put 2 in, I would get a positive value. So I'm looking for this guy to be less than 0, so I'm interested in the interval between these two here. That's where it's negative. And we're going to be between -4. Since it cannot be 1, we have to have a soft bracket there, regardless if any are equal to. Not a problem in this case. And then just writing out our value in interval notation, it would be between -4 and +1, with both having soft brackets. Looking at problem number 7, there's only one number that would drive that denominator to 0, so I know x cannot equal 0. Looking at the top part, again, it's the numerator that tells us where the zeros are going to occur. That is factorable, so it's going to be x. We're looking for two numbers that multiply to be 8, that add to be 6, so that's 4 and 2. Since this is a plus, they're both going to be positive. So I know x equals -4, x equals -2. So we have three critical values in this case. We have -4, -2, and then we have 0. That gives us 4 intervals to test. So let's say you put -5 in, you'd get a negative value. If you put -3 in, you'd get a positive value. And we wind up with minus plus like that. I'm looking for the intervals where it's going to be less than 0. So that's going to bring me to this interval over here and this interval over here. So I'm at -4, and the other one that I'm interested in now is -2. And then we also need to put on there our 0. So I want it to be less than 0. So I'm going to have a soft bracket here heading towards -infinity. I'm going to pick up on the other side of -2 and then to 0. 0 has to have a soft bracket because, again, that's where it cannot be. Again, not an issue in this particular problem because we don't have the or equal to. All right, 2 more problems. The last two are a little bit more complicated, but not difficult. More pesky than difficult. We need to be set equal to 0. So the first thing I need to do is get the 3 to the other side. It's greater than or equal to 0. Okay, so we got the 3 on the other side. What we're going to need is common denominators. So the common denominator is going to be x minus 3. Now for the first fraction here, we have the x minus 3. There's no reason to multiply anything through. And on this guy here, we need to add an x minus 3. So we are multiplying both top and bottom by x minus 3. So that's going to, when we distribute, get us -3x plus 9. Let's combine up like terms. So we get -x plus 14. Is that right? 5 minus 3 is 2 plus 11. Excuse me. For our like. Oh, this minus 3 shouldn't be here. Woo! I am so sorry, guys. So it is minus plus 14. And the bottom we have x minus 3. So I know that x cannot equal 3, so that's a critical value. And if you were to solve the numerator, we would find that x would equal 14 to drive it to 0. So we're looking at our intervals of 3 and 14. If we're to plug values in, we get a minus, plus, and a minus value here. We're looking for this guy to be greater than or equal to 3. So in interval notation, it's going to be between the 3 with a hard bracket, a soft bracket, because that's where x cannot equal. So I know soft bracket's going there, and between 14 with a hard bracket. So we would have 3 and 14, soft bracket here, hard bracket over there, and all values in between. All right, I'm just going to scoot this guy up a little bit so we can see the number line a little bit better for the next one. All right, so again, first thing we got to do is get this guy equal to 0. So we're going to subtract everything from the right over to the left. All right, so again, in order to add or subtract fractions, we are going to need that common denominator. The common denominator is going to be x plus 1, x minus 1. What we're missing on this side of the equation here is the x minus 1. So I'm going to multiply both top and bottom by x minus 1. On the other side here, I'm going to put up a big bracket, because anytime we have a minus and there's additional terms, I like to put up a big bracket to make sure I distribute through. But what we're missing here is the x plus 1, so we're going to have x plus 1 squared. Let's start multiplying all this out. So we're still over x plus 1, x minus 1. When we FOIL this guy out here, what we're going to wind up with is 2x squared plus 3x minus 5. Keeping my big bracket up again because of the minus sign. I want to make sure I catch everything. FOILing out the x plus 1 squared, we get, let's see, x squared plus 2x plus 1. Let's continue over here. So we're still over x plus 1, x minus 1. Not doing anything with the terms on the left piece here. I am going to distribute this negative through to all three terms. So we're going to get minus x squared, minus 2x, minus 1. Let's combine up our like terms. Still have our denominator. We're going to get just x squared. Combining up the x terms, we're going to get plus x minus 6. So now, looking at the denominator, now we got them combined. X cannot be 1. X cannot be also negative 1. So it can't be either of those. What's going to make this particular rational equation go to 0 on the numerator, that's what we're looking for. That is factorable into x plus 3, x minus 2. So I know x is going to equal negative 3, x is going to equal 2. So, oh, that doesn't look like a 3. Now it looks like a 3. Actually, Mr. Seamus just walked in and fell on top of the garbage can and scared me. That's why I messed up. Anyway, so our critical values are where x cannot equal, so that's 1 and negative 1. And we also have negative 3 and a positive 2. Again, plugging in values in those intervals, I wind up with a plus, minus, and a plus. We're looking for this to be greater than 0. So we're looking at all the intervals where it's going to be positive. So it's going to be between negative infinity and negative 3 soft bracket. We're going to pick up again at negative 1 to positive 1, and that's where it can't be 0. Now we don't have the r equal to, so it's not an issue, but if it did, these would remain soft brackets regardless. Unions with 2 to infinity, and just getting that on the number line, minus 3, negative 1, 1, and 2, all with soft brackets heading this way, in between those two, and in the other direction. And that is it for 7.3, everybody.